Yo, yo, Algebrainiacs! Welcome to the Johnson Kendall Video Hour.
But it's not an hour.
Alrighty. Well, look at your K on there. That's kind of cool. Like you're throwing a ball or something. That's a person. Hey, dot, dot, dot. We're thinking. Okay, back to reality here. 11.3 probability of multiple events. Okay, meaning more than one. I heart math. Yeah, baby. Okay. Dependent event. So one depends on the other. So when one event affects how a second event can occur.
For instance, socks.
Socks.
Out of the drawer.
All right. Well, yeah, I want to take the same color socks out of there. So if I take a black one, I don't want to take a blue one.
Well, and if you take a black one out, there are less black ones to choose from.
True. Yes.
So what happens first affects what happens second.
Right on.
Versus independent event.
Versus wearing no socks.
I don't like socks anyway.
All right.
Well, I mean, I like sandals, that's what I mean.
Okay.
I wear socks.
Too bad we can't go barefoot at school. Life would be good.
Yeah.
All right, independent event is when one event does not affect the other. So like taking a glass of milk from the fridge and then getting cookies out of the cupboard. They don't affect each other. How many cookies I can take and how much milk. All right, well, let's try it. Let's see if we can figure these out. So if I roll a number cube,
What's a number cube?
it's the same thing as a die, which is singular for dice.
But your book calls it a number cube.
Right. And then I spin a spinner. Do those affect each other?
No.
No. We can do one without worrying about what the other one is. All right, next one. So you pick a flashcard, then you pick another one from a stack of 30.
Definitely affects the other one.
Right, because if you took one out, now there's only 29, so your probabilities are going to change because your total has changed. Okay. Next one, you select a coin at random, then you replace it, and you select again.
Ooh, that's tricky because we put it back.
Then your total's the same.
Yeah.
So that'd be independent. They do not depend on each other for their probabilities. All right, independent events. So we read this as probability of A and B. All you do is you take the probability of A and you multiply it by the probability of B.
As long as they're independent.
Yes, this only works for independent.
Okay.
Let's try one. Okay, you're at a picnic. You have 10 diet drinks and 5 regular drinks. So how many drinks total?
15.
Okay, well, let's write that down somewhere because we might need the total when we're dealing with probability. Then there are also 8 bags of fat-free chips.
Ew.
Ew. And 12 bags of regular chips. How many total?
I wasn't
8
paying
and
attention.
12 makes 20. Good. If you grab a drink and grab a bag of chips without looking because you're in a hurry to get to the volleyball game, what's the probability you'll get a diet drink and a fat-free chip?
Well, we have to determine whether these are independent or not. And I think that chips is like your milk and your cookies.
Yeah,
they don't have anything.
They don't affect each other.
Okay, so let's do probability of diet. That can be our event A.
Okay.
And fat free.
Fat.
Well,
Fat.
that makes sense.
That's perfect. Okay, we know what we're talking about.
That's
So
our event B.
probability of diet. So how many diet drinks are there?
There are
Looks like
10 diet drinks, but that's out of 15.
Okay, and then we're going to multiply by fat-free chips.
There are 20, and 8 are fat-free.
Okay, then we just multiply straight across.
Can't we do that cool thing where you do the slashy diagonals?
Oh, heck yeah, that makes it easier. So you can either do a cross now or cancel again. 4 and a 1, so 4 out of 15.
Cool.
And then you can change that to a decimal and percent, but 4 out of 15 is good enough.
All right. Cool.
Next. All right.
Mutually exclusive events. These are events that cannot happen at the same time. So things like, for example,
how about a deck of cards?
Okay, so things like drawing a club
Yeah.
and drawing a red card.
Yeah, You
Those
can't
are
do that at the same time.
Yeah.
They're totally different.
they're
Can't happen.
right. It's impossible to have any overlap. My brain thinks about those Venn diagrams.
All right, let's see if these are mutually exclusive.
Rolling a 2 and a 3 on a number cube?
With one roll of the die, can you roll a 2 and a 3?
No.
No. So these are mutually exclusive.
Rolling a number 6 and an even number.
Well, 6 is an even number,
So
so
they
that
can happen at the same time. So that is not.
M-E.
All right. So now we're going to talk about or. We just did and. Now we will do or. So there is a little formula. Probability of event A or B is equal to the probability of A plus the probability of B. Then you have to subtract the overlap. Right. That would be like the even sixes, whatever makes them both true.
Happening at the same time.
Right. So that's an or. And then if your events are mutually exclusive, what is the overlap if your events are mutually exclusive?
There is no overlap because they don't overlap.
Right. So then there's nothing to subtract. So really it's the same formula. It just ends up that your overlap is 0.
Got it.
Okay, so we add those formulas together. Cool. All right, here we go. At Spring Lake, a student can take one foreign language class each term. About 50% take Spanish, 30% of students takes French. What is the probability that a student chosen at random takes Spanish or French? So our handy dandy formula says that we can take the individual probabilities and add them together. And then subtract the overlap, but I don't think there can be an overlap because it's underlined up there. We can only take one foreign language at a time. So that would be 50% plus 30%, so 80%. So that means if you pick a random student, there's an 80% chance that they are either in Spanish or French. All right, next one. Suppose you reach into a dish and select a token at random. What is the probability that the token is round, oh, very nice, or green?
Okay. Try to move them at the same time.
I don't think you can do that. Yeah, not on the smart board.
Round.
Or green. So those definitely are not mutually exclusive events because there are a couple examples that are both round and green. So we're going to have to use that formula. Take the probability of round, add it to the probability of green, and then subtract the overlap, which is the round green ones, round and green. Okay, probability of round. There are 1, 2, 3 round out of 7 tokens. And then the green ones, there are, ooh, you're using green, very nice. 1, 2, 3 out of 7. And then we need to remove the overlap. So those would be any that make round and green true. There are 2. Can I do that reducey slashy thing we talked about?
No, that's only with multiplication.
Oh yeah, I remember. So 6 sevenths minus 2 sevenths, we get 4 sevenths as our probability. And you may write it as a decimal or a fraction if you wish. All right. I think that's it. Probably time to, maybe we should make it last an hour. Could we go on for an hour?
I could sing a couple songs. What can you do?
I don't know. We sang Spanish verb songs today.
Whoa. Here. I know that
To
one.
go.
All right. Okay, I think it's time to go.
Here!